All right, last page. All right, so infinite limits. So what we have here, and we kind of discussed this already, is a specific or special scenario in which limits are going to infinity, but typically what we say, which we said on the previous page, is that they don't exist. So if we're looking at a right-handed limit or even a left-handed limit where the graph is going to positive or negative infinity, we typically say, okay, that limit doesn't exist because it's going somewhere that has no end, right? But you can also phrase it as going to positive or negative infinity. So here it says sometimes the limit as x approaches a given a value does not exist because x is assigned values that approach a corresponding y value that will continue to grow larger without bound. So here, what this means is that when we have a given f of x, which is our y value, that will grow larger without bound, meaning it will continue to get bigger and bigger and bigger, we say that the limit as x approaches this given a value of f of x is equal to infinity. Now, it's not incorrect to say that it doesn't exist. It just doesn't exist in a very special way. So one thing you need to consider is if you're looking at a graph and the graph approaches 2 from the left and y is equal to 5, and then you approach from the right and it's negative 1, that limit overall definitely doesn't exist, right? Because the graph is not meeting up. But if both sides are going up and maybe approaching a vertical asymptote, going to positive infinity, it's a special behavior. Both ends of that graph are going to positive infinity. So on a multiple choice question, you will not see does not exist and positive infinity because essentially those are the same thing, true? You could say both answers, so that would be a trick question. Okay, but what you need to get used to is if your graph is heading in the same direction, approaching a vertical asymptote or some strange scenario with the graph, and they're both either positive or negative infinity, you want to get in the habit of answering as positive or negative infinity, whereas a scenario like this would be does not exist. Everybody understand the difference? Okay, so then here it says that, just as I said, the limit as x approaches a being equal to positive infinity still means that the limit does not exist. It just does it in a special way. So then if your limit as x approaches a of f of x is equal to negative infinity, it just means that your y values will become smaller without bound, okay, as x approaches that given value. So here, again, we have a graph. We're going to take a look at these scenarios. And I know these, again, exponents are super tiny, okay? But we've got the limit as x approaches 2 only from the right. We are going from the right. So here we are at 2, and we're approaching from the right. What would you say that is? I would agree. I would say 1. So what about the limit as x approaches negative 2 from the left? This is a special case. I would say positive infinity. Now that we have spoken about infinite limits, you want to use positive infinity. Okay, my infinity symbol is, that's it. Okay? What about the limit as x approaches negative 2 overall? Yeah, I would go to positive infinity. Okay. Does everyone agree? Because both ends are going to the same value, or headed towards the same value, which in this case is not really a value, it's just infinity. Okay, in this, you can barely even see this, but the limit as x approaches negative 3. I don't think there's an exponent there. It doesn't look like it. Regular 3. Thank you. 3. Is it 3? Are you sure it's from the left? Woo! I need glasses. All right, so as x approaches negative 3, and we'll make it more obvious from the left. From the left, yes, positive infinity. And I'm assuming this is from the right? Ooh, buddy. All right, positive infinity. So what would we say this is? Yes, I agree. So then what about the limit overall? Definitely doesn't exist. Okay, it should take you, I don't know, 10 seconds to do the next one. So this one is from the right. This one is from the left. You can see that one, and that's overall. Okay, 0 from the right. Positive infinity. Okay, 0 from the left. Ooh, negative infinity. So they're going in different directions. Does not exist. That's right. Okay, questions before we sketch the next graph?
Is it too early to ask if the limit is going toward infinity, would the limit still be infinity, or would it be does not exist?
Say it one more time.
So if x is going toward infinity, would the limit still be infinity, or would it be does not
As
exist?
x approaches infinity, you have to see, you can't say for sure. I'm actually going to talk about that right now, because if you have a limit as x is approaching infinity, what you're saying is your x values are going to increase without bound, and what you want to know is it's possible that your graph could also increase without bound, or it could approach a given value, meaning a horizontal asymptote. So it depends on the function, and it depends on what you're given.
It's not going about, like it's no asymptote, it's just going up.
Okay, so if you're looking, but you're asking if the limit as x approaches infinity,
Yes.
and you're looking at a graph,
And the graph is just going without bound.
yeah, then you would say infinity. You would have to see what the behavior of the graph is. Yeah. So here, like if it's this graph or something like that, as the limit as x is approaching infinity, meaning your graph is just continuing on, there's no vertical or horizontal asymptote. Like here, this implies that there's an asymptote because it looks like it's approaching 0. Okay? But in this case, you're saying if this continued to go off.
Yes.
So as x approaches positive infinity, based on what I can see from this graph, I would conclude if there was an arrow here, okay, that it would be going to positive infinity. Okay, but you have to look at the behavior of the graph. In this case, there's no arrow, so I couldn't say that. Here, you would say the limit as x approaches positive infinity, it would be 5, because it appears as though it stops. It's like a segment.
I've just questioned this a lot since infinity is not supposed to really have a limit, but it does when it's approaching
Conceptually,
infinity.
though, you're describing what the behavior is.
Okay.
When you say that something is going to infinity, you're saying that those y values are increasing without bound,
Okay.
meaning there is nothing that's going to stop them from getting infinitely larger. Does that make sense? Okay. Any other questions? Okay. This last piece here, I will, I don't want to say warn you, but I'm just going to caution you that you do need to practice these graphs, because it does take practice. I mean, how often do you graph? You graph every day? You are an exception to the rule, my friend. But, I mean, it's not something that we do on the daily, right? For those of us that don't really like to do it, we try to avoid it as much as possible. But I'll tell you right now, you do need to know how to do this. So, we are looking at behaviors and what is happening. And a lot of times, the easiest thing to do here is graph what you are familiar with first, and then go to the stuff that you're least comfortable with second to see what the behavior is.